Hello again, guys. We're gonna be doing worksheets on the introduction of organic chemistry on this video. So we're gonna get started with the first question. Now it is asking us the general formulas for alkanes. It is from those slides you remember: CnH2n plus 2. Alkenes are CnH2n. Alkynes are CnH2n minus 2. I'm just going to write here cycloalkane as well. It is CnH2n2. So you see alkenes and cycloalkenes, they have the same thing. The only difference is that cycloalkane loses 2 hydrogens because of the ring. Okay, so now alkanes are saturated hydrocarbons. What does this mean? It means that full with hydrogens, all single bonds. That's what it means. And what does unsaturated hydrocarbon means? Provide general examples of unsaturated hydrocarbons. So unsaturated means that we have less hydrogen than alkanes, and the formulas of them, we can write them, but they need to have double bonds or triple bond. And the examples are, we have alkenes, alkyne, and aromatic, etc. Okay, so now we'll go to question 4. Looking at the chemical formula of this compound, which one is alkane? So we said the alkane formula is CnH2n plus 2. If you check all these guys in here, only this one fits in the criteria, because 3 times 2 plus 2, it is 8. So this the only one, but this guy is not going to fit. This is alkene, and this is alkene as well, or it could be cyclopentane, because they have the same formula, but it's not a cyclopentane is cycloalkane, right? But it is not alkane. So only alkane is this guy, A. I'm just going to erase this so you guys can see it. So now we go to question 5. Which of the following is an alkane? And out of here, we only have this one, which is closer to answer, which is not the actual answer. This guy is cyclo. You see this hexane, the ending is ane. So cyclohexane is cycloalkane, but it is not alkane, it is cyclo. So we can choose this one as an answer, but it's still not the full answer. Okay. Question 6. Provide the names and general formula for 10 alkanes, alkenes, and alkynes. So for this one, I'm just going to go down and I will write it here. Actually, I'll write it on the side. So the first carbon, we know that it is meth, right? So the alkanes has an ending of alkane, right? So it'll be methane. And then second carbon is eth. It is ethane for alkanes, but for alkene it is ethene, and then for alkyne it'll be ethyne. Just the same ending. So I'm not going to write it for all of them, the endings, they give you example, but I'm going to fill the three all the numbers for carbon. So meth, eth, and then we have here prop, and then 4 is but, 5 is pent, 6 is hex, 7 is hept. We will cover this in nomenclature too. 8 is oct, 9 is non, 10 is dec. Okay, so for alkane it will be propane, butane, pentane, hexane, and then for alkene it will be propene, butene, pentene, and then for alkyne it will be propene, propyne, butyne, pentyne, and hexyne, and so on. But remember this, the one carbon is only for alkane. Alkene and alkyne, they do not have one carbon, okay? They start from second carbon. It's 2 carbon and 3 carbon and so on. So now we're gonna go into question 7. Structure of the some organic compounds are shown below. Okay, so they are shown below here, so I'm just gonna leave this part like this. So are shown below. Now it is telling us which compounds are alkanes. So out of here, this guy is not alkane because it has a double bond. This guy is alkane because it has only single bonds. You see, only single bonds. And it's not a cycle, it's not a ring, so this guy is alkane. And this guy, if you look at here, we have a double bond, it is alkene. And you can compare the formula, CnH2n, CnH2n plus 2. Just count the number of carbons and hydrogens on each, and you can confirm it with me. And then it's asking aromatic one, so this guy is the aromatic one, because you have 6 carbons, and then you have 3 double bonds. So 3 double bond, that's why it's aromatic. Now this guy is cycloalkane, and this one is alkane as well, because we have only 2 carbons with a single bonds. Name each compound. Now this one, you know that 2 carbons is eth, so it's gonna be ethane. And this guy is have 3 carbons, it is propane. And this guy has 1 double bond, it is alkene, so it is gonna be called 3 carbon is prop, and then gonna be propene. And then we have here 1 carbon, 2, 3, and 4. It'll be, because 4 carbons is but, and if we have only single bonds like this, it is cycloalkane, so cyclobutane. And then for this one, for this guy, look at here, I have a double bond and I have 6 carbons. So 6 carbon is hex. If you look at here, it is hex. And then we have here a double bond, it is hexene. And because it is in a ring, it is, or cycle, we're gonna call it cyclohexene, okay? So these are the names. Draw the line structure for each compound. So for F compound is already in a line structure, so I'm not gonna do this. But for aromatic one, I'm gonna do, for this guy, this looks like this. Okay, so line structure is like this, and I have a double bond over here. So this is for E. And then for D, it just looks like a line. That's it. Okay, now for C, I'm gonna draw it here. So because I have 3 carbons, you see, I got 3 carbons here, and I have 1 double bond. So I draw 3 carbons like this, 1, 2, 3, and then I have a double bond. I'm just gonna delete this guy, so it looks like this. Okay, a line like this, a line, and a line like that. And for B, I'm gonna draw 3 carbons, so it is like this. This is the line structure. And for A, I will draw it here. So because I have 6 carbons, see 6 carbons in a ring, and I have a double bond, so I will draw it like this, 6 carbons, and then I will put in double bond like that. Okay, so this is my line structure. Okay, now question 8. Provide the expanded and line formula for the 10 alkenes, alkenes. So I'm gonna write down a few of them, not all of them. Actually, I will show one example. So expanded one, I'm gonna show you butane. Okay, so butane is like this. I have 4 carbons, right? 4 carbons, and then hydrogen is gonna be 2 times 4 plus 2 is 10. So I got 4 carbons, CH3, CH2, CH2, and CH3. This is the condensed form. But the expanded form will be like this: carbon, 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 and then I have like here. So I'll put hydrogens around it. You see, each carbon has 4 bonds. And then I'm gonna draw you the line diagram. So it'll be like this. So as if you count it, it'll be 1, 2, 3, 4 carbons. Okay, so this is the line diagram for butane, just like that. Now we're gonna go into question 9. Draw the structures of butane and isobutane. Explain which one has a linear and which one has a branched structure. Okay, so butane is the one I have driven here. You see, this is my butane. This is expanded form. This is line structure, and this is condensed. Now I'm gonna draw you an isobutane, and isobutane is like this. I got 4 carbons, okay, and then I have another carbon coming out of here. Okay, so it'll be CH3, CH3, CH2, CH3, and CH. You guys need to understand why I put certain number of hydrogens. Because I have a 1 bond here, I have only 3 valency left, so I put 3 hydrogens here. Because I have 2 carbons, 2 bonds on this carbon, I have 2 valency left, so I put 2 hydrogens. Because I have 3 bonds in here, I have only 1 valency left, so I put 1 hydrogens, and so on. So this is isobutane. Now I will draw you the line shape of it. I have 4 carbons like this, and I put this, the other one, just like that. So if you look at this guy, this one, the butane one, is in a line form. But the isobutane has a branch. You see the branch? It's here and here. So butane is in a line form, but isobutane has a branch. Okay. So now it's asking us provide possible structure for isopentane, isohexane, isooctane, nonane, and decane. So I'm just gonna draw you guys isohexane, and then I'll leave you rest for you to do. So isohexane, hexane we said is how many carbons here? We got 6, right? So I come here, isohexane, I got 6 carbon, it'll be 6 carbons. So I'm just gonna draw 6 like this. Okay, so 1, 2, 3, 4, 5, 6 carbons, right? And then I put 1 methyl group like this. We will cover the methyl group in nomenclature as well. So this is isohexane. Okay, isohexane. This is the line form. Now if you want, you can do condensed, expanded, and all of the good stuff. Okay, now I'm moving on the second worksheet. Now I have all of these compounds, and the tasks are given below. It's telling us identify saturated, unsaturated, identify open and closed chain, identify type of class for each hydrocarbon, type of class, identify straight and branch chains, identify long chain in each hydrocarbon. Okay, so let's do we're gonna name saturated and unsaturated like this. S is gonna be saturated, unsaturated will be U, and then O would be open and closed would be C. Identify type of class for each hydrocarbon. So we're gonna write name like alkane, or and so on. And then straight and branched, we're gonna just write straight, and then we'll say branched if it's branched. Identify long chain on each hydrocarbon. So longest chain we're gonna identify with this color. Okay, so let's do this one. So straight is like this. So saturated, as you guys can see, it's all single bonds in here. Because if you look at this carbon, I have one bond here, right? And then I have left 3 valencies, so I put 3 hydrogens. And because this carbon is connected from 2 sides, it has only 2 bonds left to fill, and it will be CH2. So overall, that's why this guy has only single bonds, so it is saturated. So let's find about this guy. In the second, it is saturated as well because only single bonds. And then this one, third one, it is, as you can see, we have a double bond here, so it is unsaturated. The fourth one, you guys can see that I have no double bonds, so it is saturated. And then here I have what double bond, so it is unsaturated. And here I have a ring, but no double bond, so it is saturated. But in here, if you look the line structure, I have here a triple bond. That means that it is unsaturated. Okay, so now we're gonna look at 8. As you can see here, no double bonds, so it is saturated. And this guy in here, it is CH3, so all single bonds, so saturated. And this one is here, all single bonds as well. So 2 is here, 3 is here. There's a little bit of a problem with printing, on the document. So it is saturated because of all single bonds. I have here double bonds, so it is unsaturated. And this guy here, you see we have a double bond here, so it is unsaturated. This one has 3 double bonds, it's aromatic. It is 3 double bonds, it is aromatic. So it is unsaturated. As you can see over here, we have on this guy no double bonds, so it is saturated. 15 we have a double bond here, it is unsaturated. And then this guy here, it's all single bonds, CH2, CH3, and then it is going to be saturated. And then we have no double bonds on this guy, so it is saturated as well. Now identify open closed chain structure. So from here, as you can see, these are pretty much all of them are open. This is open, okay? It's all open. This guy is open. We have no ring, no cycle. So this is open as well, but this we have is partially closed because we have a ring here, okay? And then if you look at this guy is open as well, we only have a chain. This one is closed because we have a ring. And then this guy is open because it's all in a chain fashion. So this one is open. This one is open as well. This guy is open. This one is closed because we have a cycle or a ring. This one is closed because we have a ring. This one is open, only chain, and then open and open. Okay, now it's asking identify type of class for each hydrocarbon. Okay, so because this guy has only single bonds, it is alkane. Okay, this one is alkane as well for the same reason, alkane, only single bonds. Because I have a double bond here, it'll be alkene. Okay, and this one here have alkanes, but we have this cycle in here, so it'll be cycloalkane. Okay, and this guy has a double bond here, it is alkene. And we have here a cycle, that's why it becomes cycloalkane. And then here we have a triple bond, that's why it'll be alkyne. And then on this one here, it's all single bonds, so it is alkane. It's alkanes are hydrocarbons. I just wanted to remind you. So in here we have nothing but alkane, all single bonds. And then here this guy is alkane as well. All single bonds. We have double bond here. It is alkene. Alkene. We have a double bond and a ring, so it'll be cycloalkene. And this guy is aromatic, and then because we have a ring, this ring itself is called benzene, but the group it belongs to is called phenyl group. Okay, just have this in mind. And then this one is only, you can see here, is just a line shape like this. So it is alkane. This guy has a double bond, is alkene. And this one here is alkane as well, all single bonds. And this one here, alkane as well, all single bonds. And then identify straight and branch chain, and then identify long chain in each carbon. So straight and branch chain, and then we're going to identify the long chain. So you see here, this guy is just a straight chain, right? So this is going to be straight, okay? And the longest chain is this one that I put with this, with the marker. And then look at this guy. I have the longest chain like this, but I have branches. So the longest chain is shown with the green, but this guy is branched. You can see I have two branches, right? And then if you look at this guy as well, I have a longest chain is this one, but I have, so my longest chain is this one, but I have a branch, two branches, so this one is branched as well. And then for this guy here, I have, so the longest chain is, it's not even a chain, it's a ring, but I have two branches, you see. So this one is branched. And then for this guy, the longest, I'm gonna do this mistake, yeah, the longest is this one, and it has no branch, so it's straight. And for this guy, I have here just a ring, so it'll be straight. And for this guy, you can see I have a longest chain like this, and my branch is here, so that's why it will be branched. And then for this one, we're gonna go with the longest chain, which is this, and my branches are these two methyl groups, so this guy is branched as well. And then for this guy, the longest chain, let's look at this one, so it will be, the longest chain is this, and we got three branches, so that's guy, this guy is branched. And for this guy, the longest chain is this, and I have three branches, you can see, so this one is branched as well. And then for this guy, I have, for 11, I got the branch going like this, and my branches are these two. Okay, so this is the reason it has branched version. And then for 12 I have a ring, so it has no branch, so we're gonna go with the straight for this one. And then for this guy I have a ring, no branch, so it will be straight as well. But in here for 14 you can see I noted with the green the longest chain, but my branches are here, so this one is branched as well. And for this guy I have a longest chain like this, and I have no branch, so it will be straight. And then for 17, look, it's either this one as a, so longest chain is this, and then my branch is here. I got two, so this is branched. And then 17, I got here the longest chain is this, and I have two branches. So that's why this guy is branched as well. Now we're in the next worksheet that we're gonna go. So we're gonna write down which of these compounds are organic and inorganic one in the first question. So this guy is, as you see, I have carbon, hydrogen, oxygen. It is not a hydrocarbon, but it is organic. It's ethanol. Okay, and this guy is ethane, if you remember the formula, CnH2n plus 2, and it is organic. While this one is calcium carbonate, it is inorganic. This is the one that I explained in our PowerPoint, and carbon monoxide is inorganic as well, very toxic gas. Okay, so for question second, I want you guys to really pay attention, because this is either gonna make it or break it for you guys in the exam, so please be careful on this. Circle all branched structures. Okay, so now we're gonna look at this. We got here how many? Seven of them, and then we're gonna circle the branched structures. If you see here, look at the first compound, it is just a chain, right? A straight chain. So we don't have any branching, okay? And if you look at this one as well, it's all straight. But if you look at this guy, if this is my longest chain, I have two branches, okay? So because I have a chain, it needs to have a beginning and end, right? End and beginning. But when I do it, I see that I couldn't cover everything and I still have the branches left. So this guy is branched, okay? So I'll circle it like this. And then if you look at this guy on the right, the longest chain, so the longest chain is this, okay? But I have two branches. I couldn't cover them when I went through the longest chain. And if you look for this one, you could see that the longest chain of carbons is this, but there is a branch, okay? This is my branch. And for the next compound, it is the longest chain, so it's not a branch, so this guy is branched as well. And for the last one, you see it's a chain, so no branching. So we only had two of them, which is first is this, and then the other one is this guy. Now it's asking us write the condensed formula for each compound. Okay, so now let's look at this. I got here 1, 2, 3, 4 carbons, right? So I'm gonna draw them here like that. Carbon, carbon, and carbon. Now you see this carbon has only another bond to this carbon, right? So because carbon has a valency of 4, that means that carbon can have only 4 bonds, right? So one of them is taken by this guy, right? I have left 1, 2, 3 3 bonds left. I fill them out with hydrogens. This is the rule. In line structures, this is the line structure. I do not draw hydrogens, okay? I don't draw them. So now let's continue. So now we're in this second carbon. Look at here. I have one bond and the other bond. So 2 bonds are taken. So if I take the other one, now I have 2 bonds, right? 2 bonds to fill. So I'm gonna fill it with hydrogens, 2 hydrogens. This is the same scenario for this carbon and the same scenario for this carbon. So this and this are the same. Okay, so this is the condensed formula. Now let's look at this guy. So 1, 2, 3, 4 carbons. 1, 2, 3, 4 carbons. And then I fill it the same way. This carbon is in the end, so I'm gonna fill it with 3 hydrogens. I will fill it with 2 hydrogens, 2 hydrogens, and 3 hydrogens. Now actually if you look in here, these guys are the same thing, okay? They are the same. They just like, they have been twisted, okay? So they have been twisted. So if you remember, we had molecules in our class, right? We could twist them around, those small molecules, the plastic ones. So it's the same thing. Now look at this guy. I got here 1 carbon, 2, and 3 carbon. So 1, 2, 3. And then I have here 4 and 5. Okay, so another carbon here and another carbon. So if you look at the center carbon, I have all 4 bonds taken. So I can't put any more hydrogen. But the carbons in the end, you see these ones, they have left with 3 bonds to fill because carbon needs to have 4 bonds, right? So I'm gonna fill it with hydrogens because I cannot put hydrogens in a line diagram as you can see here. Okay, so this is the condensed form. And then I'm gonna go into this guy. So here I have 1, 2, 3, 4 carbons, right? So I draw it like this, 4. Okay, and then I'm gonna put 1 carbon here and 1 carbon here. So you see the center carbon, it has 4 bonds, right? So there is no hydrogen left for this guy to fill. It filled all the 4 bonds that he can have. And then the other carbons though, they can go up to 4 bonds. So because for example, this guy in here is left with 3 bonds to fill, I'm gonna fill the rest with 3 hydrogens. It's the same thing for this guy, for this guy, but the one in the middle, I have 2 bonds attached to it, so I have left 2 hydrogens to fill, and this guy is 3 hydrogens to fill. So this is the condensed form for this, and then this one is expanded form is shown in here, and we're just gonna draw the condensed form right here. So it'll be CH3. You see I just summarized this guy into here. I'm kind of minimizing, and this hydrogen I put here like this, and then CH3 here like this, and then CH3 just like so. This is the condensed form. And then for this guy I got here 1, 2, 3, 4, 5, 6, 7 carbons. So carbon like this, and then I fill it with enough hydrogens so I can have 4 bonds. Just like so. And then look at this one. I have 1, 2, 3, 4, 5 carbons. But pay attention, I have a double bond here. See this double bond? And so now I'm gonna draw this. I have carbon, and then I draw a double bond, and then I draw like this and like this. And now I'm gonna fill with enough hydrogen so I can have the rule of 4 bonds on carbon. So because I have 1 bond taken, it'll be 3 hydrogen here. For this guy, I took all the 3, so it'll be CH. And this guy will be CH as well. It'll be CH2 on this one. It'll be CH3 on this one. So this is the condensed form for the last guy. Now, question 3, it's asking us circle a compound which contains aromatic ring. Aromatic ring, I told you guys that it needs to have a cycle of 6 carbons with 3 double bonds, okay? And if you can look into this one, I have 6 carbons here, okay? And the double bonds, I got 1 double bond here and 1 double bond here and 1 double bond on this side, but it's pretty much the same thing, whether being on this side or this side, it doesn't matter. So I got 3 double bonds and 6 carbons. 1, 2, 3, 4, 5, 6 carbons. So this is the guy that has an aromatic ring. Okay, now we move on to the next PowerPoint. Explain what is the meaning of the term saturated, unsaturated. I think I already told, so saturated one means that only single bonds, single bond. And then unsaturated means double and or triple bonds. So this one is full of hydrogen, and this one not enough hydrogen. Okay, I would say not we're not going to say not enough, but it'll be less hydrogens. Okay, it wouldn't be right to say not enough. It will be less hydrogen. For question 2, write the general formula for each class. Alkane we did already. I'm just going to write it here. 2n plus 2. Alkane is CnH2n. Alkyne is CnH2n minus 2. Cycloalkane is CnH2n. Aromatic hydrocarbons, because we have C6H6 CnH, I believe 2n minus 6. Okay, so this is the formula for aromatic hydrocarbons. Match the compounds. So organic ones are this. I think we did this B and C, this question, and inorganic is A and D. Okay, now it's asking what's the meaning of the functional group. So functional group is any attachment to the group that makes it a different chemical compound, like it reacts differently due to that functionality. For example, alkenes, I told you guys, it has a double bond, but alkanes have only single bonds. Now, this is one functional group, and this is another functional group. Now we also have alkynes. Now, if you have so this triple bond is one functional group, all single bonds is another functional group, and double bonds is another functional group. I showed you the list of them. We also have aldehyde, which is carbon double bond and hydrogens. We also have ketones. Okay, so this is aldehyde. Ketone is this guy, and the alcohol is, for example, COH. This is alcohol. This is another OH functional group. Okay, now it's asking us what is the functional group for each group. So I already answered this one, so this goes to alkenes. Alkynes is this one. Okay, and then I meant to say this is alkane, this is alkene, and this is alkyne. And now we go to the last question. Draw all structural diagrams for given compounds. Write the names of each diagram. So this is the molecular formula, right? C7H12. So if you look at the CNH, the formula of it, it looks like CnH2n minus 2, because 7 times 2 minus 2, it is 12. So this guy is alkyne. Okay, so now I'm gonna draw you guys a chain of this guy, a chain. This one is gonna be, so 1, 2, 3, 4, 5, 6, and 7. This is skeleton. Okay, this is CnH12 is molecular formula. And then structural diagram, I'm gonna show you guys an expanded form. So I got carbon, and then, but I forgot about the triple bond, sorry. So the triple bond, I can put it right here. So now I'm gonna make the expanded form. So 1, 2, 3, 4, 5, 6, and 7. Doesn't matter, they are all red in here. And then I put my triple bond here. I just chose this triple bond. You can put it here, it doesn't matter. But we know that we gotta have a triple bond. Now I'm gonna, this is expanded form. So I'm gonna put the hydrogens. So CH, so I fill them up to have 4 bonds. See, and then 4, 4. So I didn't put any hydrogen on this guy because I already have 4 bonds. Okay, so this is expanded. And then now I'm gonna draw the condensed form. It'll be, I'm just gonna summarize all this now. CH3, CH2, 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 and then I have C, and CH3. Just like this. This is, so this is expanded, this is condensed, this is skeleton, this is molecular formula. Now I'm gonna draw you guys the line diagram. So because I have 7 carbons, right? So 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7 carbons. And then I put the triple bond here, and that's it. And this is the line. The easiest one is the line 1 to 0. Okay, so now let's look at CH18. So this was A. And then we put B, C8, H18. So if we put the formula CnH, it is going to be 2n plus 2, because 8 times 2 plus 2 is 18, right? So this is alkane, we know this. So I'm just going to draw, this is the molecular formula. Now I'm gonna draw you guys the expanded form, actually skeleton. So let's do skeleton, and then below we'll do expanded, and then condensed, and then line. Okay, so this time I'm just gonna go backwards. So the line, I have 8 carbons, right? So let's count it. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is the line one. And then condensed one, it'll be, okay, 2, 3, 4, 5, sorry, 6, 7, and 8. This is the condensed form. Expanded form will be like this. So 5, 6, 7, and 8. Okay, and then I'm gonna fill with hydrogens. Okay, I'm just gonna put the bonds first. Okay, so I'll put the hydrogens now. These are all hydrogens. Okay, and skeleton would be just like this. 1, 2, 3, 4, 5, 6, 7, and 8. And that's it. And the name of this guy, just to say, so 8 is oct, and because the ending is ane, it is octane. And for this guy, we got 7 carbons, 7 is hept, and because we have the alkyne, it'll be heptyne. Okay, I hope this helps, guys. I think we went through everything, so I'm gonna do more worksheet for the other topics. Thank you very much.